Back. I crashed on the last one. Sorry about that. This thing back. Okay. Hopefully. Okay, so it says a man standing on the roof of a building 58 feet high looks down down to the building next door. So we need two buildings. It's too big, right? That. Let's go back to that. Got a building. This building's 8 feet high. Next door is down somewhat. How far down? And there's a little man standing on top of it. It's probably really tall. If this is to scale, that's a huge person. Not actually. Maybe that's. And so he looks down to the top of the building next door. He finds the angle of depression to the roof of that building from the roof of his building. So he's looking down to this point here from his building. And the angle of depression, which is this angle, finds to be 7 degrees. While the angle of depression from the roof, okay, the angle of depression from his roof, bottom, next door, is different, obviously. This one is this one is finds the angle of depression to that building, this building. Depression from his building to the bottom of the building, 63. That is not possible. I wonder if I'm not misreading this. Standing on high, looks down to the building next door. Finds the angle of depression to that building on his building, 7 degrees. While the angle of depression from the roof of his building, bottom of the building next door, is 63. Very interesting. The only thing that I could think is they mean an elevation. So like this angle and this angle. But I don't think so. I think how tall is the building next door? Or they switch them. Yeah, so this textbook manufacturer needs to get his stuff together. This is embarrassing. I'm the idiot. I don't know. So okay, let's just pretend like this is possible and see what happens. I don't know what will happen. This is 63.6 degrees. So then this thing, this thing. This is 58. It's 58. essentially what we're looking at is this distance here, this side. Find this. No, that's not really contrast. Self in after. Today I'm gonna be all fancy like ahead of time. Okay. So that's the length that we're. I want to find this thing first. So let's find x here. I'll use, if this angle is 63, that means this angle is the complement of that. So 90 minus 63, 6. 60 is 30. 7. 6 is 6.4. This is 26.4. Which means, okay. Let's do the cosine of 58. I'm sorry, the cosine of 63.6 degrees. Adjacent over the, yeah, we do need this, the adjacent relationship here. About the tangent. Tangent 6 degrees x over. Then we can multiply by 58 on both sides. Six, and that x is equal to something. $116. Just gonna put the approximate value for this. Say 117. When I do this in my calculator, I'm going to use the full value from that. I'm not going to use the rounded value. Okay, so now we have x, which means that that is the same as this x up here, same length. Should be able to find this height, but it's not going to make sense. It's going to be like, so let's call this little green segment y, and so we can see tangent 7 is equal to x over y, and I'm going to use this full x in my calculator, but approximately 117 y, so that's so x over y is equal to, I'm sorry, we're solving for y. Solve for y. So we're going to multiply both sides by y. Divide by tangent 7. And keep in mind, this is x here and here. So I'll substitute that. I put this in my calculator. Tangent of 63.6 divided by 34. This is 168. So that is a bigger number than what we had before. So let's 68.7. Okay, so do I think this is right? No, I don't. There's a couple of possible mistakes. The computer just like messed up these angles. or they mean angle of elevation, which I don't think that's probably a mistake. I think they switched these angles is possibly the mistake, or they just coded this badly. And so I don't anybody who uses this website, the red numbers, they change, but the rest of the text doesn't change. So if someone comes along and they search this thing up, let's say I take this text and I put it in the description of the video. Someone types that into Google. They might find my video, but the 58, the 63.6, and the 34.7, those will all be different numbers. So the computer generates those somewhat randomly, probably, but it should be constrained to some range, and one of them should be less than the other for sure, but they have that relationship backwards. So I don't think this is correct, because that's taller than this building is taller than the next, unless that's what's going on. But it says looks down to the building next door, so his building should be taller. So let's draw this situation up again. And this time, what I'll do is I will switch the angles. Okay. Makes sense. So the first one says finds the angle of depression to the roof of the building next door from his building, but I think maybe they meant to the floor. And this angle is 34.7. Then again, compare to roof. So this big angle will 66. Okay, so this is 63.6. So we can find, since we know that this is 58, find x again. Here, x, and then also here is the same. Okay, so there you got the same line. Those are both x, which is important. So we'll do the tangent of 34.7 x over 58. Solve for that. X equals 58 tangent. And then we'll keep that because we need the next thing. So now we need to figure out how tall is the building next door. Oh, actually, this is just completely throw this number out because we. So now we need to figure out this length here. Let's call that y. So the tangent of 63.6 equals x over y, and solving for y, x over 63.6. So we know from our last problem, our last thing, so this is what you would throw in. Find y, and once we find y, we can height of the building. So tangent 7 divided by so 19.9 something. So I'm going to take 58 minus that. And that gives me this distance here. So the answer here is 8 minus y, which is 2. I would try this as the answer. We could have gotten the answer here, but we've gotten a negative number, and that can't be right. So they either made a mistake or I don't know. But I think this is probably the correct answer. There's no telling though. I guess there is after you did it right or wrong. Okay. There are actually a bunch of problems. After this, there's like a whole packet. Some more line of bearing problems. Just like trying to make problems harder by convention.